and touches your face as you...
Hey everyone, what's happening? So we're going to be talking about calculating molar mass today. And now molar mass is the number of grams in a mole of a substance. And we remember from the other day that a mole is just a really, really, really big number. And it turns out that it's 6.02 times 10 to the 23. And this is a number, this can be atoms, this could be molecules, or whatever, but it's a number, and it tells us, and it's a very, very large number. Okay, so for the molar mass for every element is given on the periodic table. Let's check it out. So if you look at carbon here, so what that says, if you look at where my cursor is, I've got carbon is 12 grams. That's the atomic mass. Well, pretty cool is that 12 grams, what that says is 12 grams of carbon equal 1 mole. So 6.02 times 10 to the 23 carbon atoms weigh 12 grams, which is pretty cool. Okay, so what we can do is we can calculate the molar mass of certain things. So if we take a look at oxygen, let's go back to our periodic table, and we look at oxygen, well, look at that. Oxygen is 16 grams. So we have 16 grams in 1 mole, and this is like saying it's 16 grams for every 6.02 times 10 to the 23 oxygen atoms. Next, let's take a look at NaOH, sodium hydroxide. And when we get a compound like this, what we're going to do is we're going to add them all up. So Na molar mass is 23 grams per mole, oxygen is 16 grams per mole, and H is 1 gram per mole. And if we add all these bad boys up, we get 40 grams per mole. So if we have 6.02 times 10 to the 23 NaOH molecules, they will weigh 40 grams per mole. All right, let's try a couple more. We've got potassium sulfide, and we've got K and S, and this is how I want you to set them up. So we've got 2 Ks, and K's molar mass is 39.1. We just find that on the periodic table. So potassium, look there, 39.1. And then we've got sulfur, and we've got one of those, and we have 32.1. We do our little multiplication here, and we get 78.2. And over here we get 32.1. We add these bad boys up, and we get 110.3 grams per mole. So if we have 6.02 times 10 to the 23 molecules of potassium sulfide, it will weigh 110.3 grams. Let's try ammonium sulfate. We've got N, we've got H's, we've got S, and we've got O's. All right, so, and remember this 2 affects everything. So we have 2 nitrogens, and now it affects the H here, and we're going to have 8 hydrogens. Our sulfur, oh, we only have 1, and we have 4 oxygens. We look on a periodic table of elements, and the molar mass of nitrogen is 14 grams. Hydrogen is 1 gram. Sulfur is 32.1 grams per mole, and oxygen is 16 grams. So we multiply all these bad boys out, and altogether we get 132.1 grams per mole. So just like the other one, if we had a mole of ammonium sulfate, NH4 it would weigh 132.1 grams. Copper 2 nitrate hexahydrate. All right, so we've got 1 copper, we've got a nitrogen, and we've got some oxygens, and we've got 2 nitrogens here, and we've got 6 O's right here, and we're going to combine all these in a second. Then we have 12 H's, and we also have 6 O's again, so altogether we have 12 O's. All right, so copper's molar mass is 63.5 grams per mole. Then we have nitrogen, which is 14. We have oxygen, which is 16, and hydrogen, which is 1. so now we're going to find the molar mass of this whole molecule. So if we had 6.02 times 10 to the 23 molecules of copper 2 nitrate hexahydrate, it would weigh a certain amount, and we're going to find out how much it's going to weigh. So we have 63.5, we have 28 grams, we have 192 grams, and then we have 12 grams. We add all that up, and we get 295.5 grams per mole. Isn't that crazy? Like, just think about that. You could have 6.2 times 10 to the 23 numbers of molecules of this, and it would only weigh 295.5 grams. All right. Have a good rest of the day.